So I want to talk a little bit about inheritance properties. This is something that Axler sort of dances around. The idea with inheritance is you want to know how do things like span and independence behave with respect to containment. And so for this, we'll need the idea of a sublist, what it means for one list to be a sublist of another. So I'm going to give you a definition here. Put it in quotes because it doesn't appear throughout the rest of the book, so it's not really formally part of our canon, but it's important to describe what I want to tell you here. So we say that L1 is a sublist of L2 if every element of L1 appears somewhere in L2. And since they're lists, we have to have the caveat that if V appears more than once in L1, then it appears the same number of times in L2. So I'll call that the same multiplicity. Okay, and so we'll denote this containment relation with the usual subscript, with the usual subset symbol, just a slightly different meaning. Okay, so what I want to say then is so I'll just refer to this as inheritance. So the first part is that any sublist of an independent list is independent. Okay. And the other one is that if we go the other way, spanning is preserved. So if any sublist of L spans V, then L spans spans V. Okay, and so I'm going to leave the proofs of these as exercises to you because they're both fairly short answer proofs. So for the first one, so if we have one list contained in another, for the first one, suppose let's say that L2 is independent. Well, then you're going to want to look for what would happen if you had a dependence relation in L1. And for part B, what are you going to do? Well, you're going to suppose that L1 spans V, and then you have to show that anything in V is in span L2. So I'll let you work through the details. I'm confident you can do it. To sort of see the strange symmetry between these two ideas of independence and span, I'm just going to rewrite the theorem in slightly different jargon. So if we say, let's suppose L1 is contained in as a sublist of L2. Okay, then the first one says so if the larger one is independent, it implies that the smaller one is independent. And the second one says that if L1 is spans V, then L2 spans V.